So how to calculate a height? We'll talk here about some common examples that we usually use in the exercises. So first, let's talk about an inclined plane, and I want to find the height of the point A, knowing that all I have is the length OA and the angle alpha. So these are the givens. So in order to find the height of the point A, first of all, I look to the reference. I put the height, it's from A to the reference. So I want to find this part. So it's above the reference, it's positive. It's with respect to the angle alpha, it's opposite. So بما إنه هي opposite, then I will use sine alpha, knowing that sine alpha is equal to the opposite over the hypotenuse. Now the opposite mean here to the angle alpha, it's h. And the hypotenuse is who? Is OA. So this is how I can find that sine alpha equal to the height over OA implies I can say that the height is equals to OA sine alpha. So هيك بنكون طلعناها in terms of the given that I have. Second example, now if you notice that the reference now is at the point, same figure, but the reference now is at the point O here. So it's not below. And the question is also to find the height of the point B, knowing that all I have is OB and the angle alpha and OA if I want, for example, to use it. Okay, now the question is to find the height of the point B. First of all, come in, I trace the height with respect to the reference. So this height with respect to the angle alpha is here, but by alternating, then this is also alpha. So h with respect to the angle alpha, it's opposite. This means I will use also sine alpha. The opposite is who is the height. The hypotenuse is OB. It's here. That's it. Now, this means that sine alpha equal to the height over OB. This means the height is OB sine alpha. But what if I want to find ZB? So we must pay attention that B is below the reference. This is why when I want to write it, I'll write it in this way. ZB equal to the minus height of the point B, which is equals to minus OB sine alpha. So always لازم ننتبه إنه it's below the reference or above the reference. And sometimes ما بيكون مثلا معي OB, but شو بكون عطينا given? You have OA as given and you have AB. Okay, so simply I can find OB by using OB equal to OA minus AB. Okay, but the concept won't change. Now, in this exercise, in this figure, we have a pendulum, which is if I release it, it will do like a circular trajectory. And the question here, so here you have the reference, it's here. And the question is to find the height of the point B, okay, at the point B, with this in terms of the length of the string and the angle theta, which is here. So, in order to find this height, أول شي بدنا ننتبه إنه I can't find it from outside. So what should I do? بجيب, well, this is H, so I can put it here also. It's parallel. So this is also H. So H is zeta mean, I can say that H is zeta AI. Okay? So that's it. H of the point B is zeta AI. Now, but also how to find AI? In order to find AI, I can say that AI here, this part here, is equals to OA minus OI, knowing that OA كلها هي مين? It's the length of the string. So OA is the length of the string. But we still have to find OI. Okay, how to find OI? Now I'll look at this triangle here. So in this triangle, OI, with respect to the angle theta, is adjacent. This means I will use cosine, such that cosine theta is equal to the adjacent. The adjacent is OI over the hypotenuse, where the hypotenuse is OB. It's here. And knowing that OB is at the length of the string, then here I can substitute OI here by L cosine theta. So we'll get as answer H of the point B is equal to L minus L cosine theta. Now this figure, zeta, here. It's the same as this figure. The only difference is, instead of saying that I have a length of the string, I don't have a string here. I just have a particle which is moving on this trajectory, on this circular trajectory. So I have the radius instead of having the length. But the same concept, if this is the reference here, then this will be the height. So the steps are the same. I do a parallel. This will be also the height. okay? And I put a point I here where I say that height is equal to the AI, then I can continue and find the same answer. What about the height if we have a vertical spring? Now here we have a vertical spring, free length. I connect to it an object, so it become at equilibrium. Now at equilibrium, if I want to find the height, I notice if this is the reference here, so the height is equal to 0. It's on the reference. Since it's estimated, I can estimate to a particle. Now in the third figure, the spring is elongated. So it's elongated by x, and I want to find the height. So always in order to find the height, I trace from the object to the reference. So this is the height here. So this height is equal to who? Is equal to the elongation itself, which is x. But if I wanted to write in terms of z, I must pay attention that if this is the reference here, the object is below the reference. So this means I must have z of the point A is equal to minus the height of the point A, which is minus x.